Good afternoon, everyone. Thank you for joining us for this third day of Chrome lecture series. We've got a lot of information today. We'll try to cover it in 35, maybe 40 minutes. I always like to start with a couple things. One is if you're really interested in Chrome Guided Smile, we share a lot of information on our Facebook page. In fact, that's one of our main outlets for demonstrating cases, for discussing new developments, that type of thing. But it's also private, so we only allow doctors in and staff, people who really are associated with Chrome. We don't allow vendors. So we want to keep it private. We want doctors to be able to share ideas, good experiences, bad experiences, that type of thing. And then it's really kind of a group where people can share ideas and even share a little bit of criticisms, but it's a very supportive group. So I really encourage anybody who's interested to go to Facebook and join it, and just sit tight and we'll let you in. Today's program is centered on the carrier guide and the osteotomy guide. Two of the very key components of Chrome Guided Smile. Yesterday we talked about the pin guide and the fixation base. That is the starting point of the surgery. And once you are through the bone reduction, then that's when the carrier guide and the osteotomy guide come into play. So those are our two topics for today. My name is Alan Banks. I work for Rowe Dental Laboratory. Rowe has been in business since the mid-1920s, one of the oldest laboratories in the country. We have many proprietary products. We work with patented products. A lot of them surround Chrome Guided Smile, including a couple other services that we do. It's an awfully nice place to work. It's a little quiet right now. We are still open. Look us up. We have performed Chrome Guided Smile in every state at this point. We're at about just about 6,000 cases in the past 2.5 years. So it's a tremendous, well-received product. We are excited to be behind it. So today's osteotomy guide and carrier guide. Tomorrow will be the nanoceramic prosthetic and the rapid appliance. And then on Tuesday, one of our key technicians, Joe Ambrose, will give a nice presentation on full arch analysis, which is really important for onboarding any full arch case, critiquing the patient, critiquing the records. Would recommend anyone join that, whether you're involved in full arch or other types of larger cases. Guided Smile Chrome is a culmination of years of guided surgery technology wrapped up into one industry-leading full arch product. Developed in both a clinical and laboratory environment, Chrome delivers a doctor and patient a pre-planned service for bone reduction, osteotomy creation, implant and multi-unit abutment indexing, and an integrated nanoprosthetic. There are no comparable services in the world like Chrome. It's available for nearly all implant systems, offers full visualization during surgery, minimally invasive exposure, a fully pre-planned surgery with implant indexing, a beautifully crafted and integrated prosthetic, and a level of precision planning that is unique in the industry for implants, components, and prosthetics. Chrome delivers what is expected by the patient and the doctor every time, for every patient. After patient, after patient, after happy patient. It's time you try Chrome and its family of products and services for your next full arch surgery. Okay, I'd like to share a video. Let me mention one other thing too. When I have this map of where we've completed Chrome, we also complete Chrome in a couple different continents. In Europe, we have a partner there. We have a partner in Australia, and then we have a great partner up in Canada, DLA Lab. So if you're in Canada, that's those cases they're not directly sent to us. They really go through that lab partner up there. It's a great partnership. Contact Larry anytime for those surgeries being performed in Canada. What is Chrome Guided Smile? It's a pre-planned surgery that starts with the smile simulation and ends with a predictable method of delivering the final restoration. Chrome delivers bone reduction, guidance, osteotomy guidance, implant control, abutment insertion, and a simplified prosthetic conversion, and a very simplified method of converting to the final restoration. So similar to yesterday, I want to compare Chrome to other plastic guides. I think there's a significant advantage to using metal. I think it's really kind of accepted, certainly among our users, and doctors in the know who have tried metal over plastic agree that there are significant advantages. One of them is just irrigation. With plastic guides, most, in fact, I believe all, I think they can be modified to change that aspect, but they all cover the ridge. They cover the site. They cover the access. In fact, it's kind of a blind drilling and blind placement, in my opinion, as opposed to Chrome, which you can see the image on the left. Obviously, if you can see it, you can irrigate it, and which has a huge advantage. But also, the irrigation is one part, but the visualization is the other. You know, sometimes we work with a lot of specialists, oral surgeons, periodontists, and often every time these doctors want to see the bone, feel the bone. If they're using osteotomes or any kind of in a situation where there's very narrow bone, they want to see the drills going in, the tools going in, the implants going in, sometimes even feel the bone while they are going through surgery. You can do that with Chrome. You cannot do that with plastic. So it's a huge advantage. Today, osteotomy guide and carrier guide. They are part of the sequencing of Chrome Guided Smile. It's, if you will, the third and fourth step in completing one of these cases. They are relatively simple tools compared to other systems on the market. The osteotomy guide serves a few purposes. One is it guides the spoons and the handles or the drills during surgery. There are different types of systems out there, and we will discuss each of those. They control the depth and the trajectory of the drills throughout the osteotomy creation. They don't always control the implant, and we'll talk about that a little bit. They do if they have a fully guided kit. The metal, as we discussed yesterday, the metal in the fixation base and the osteotomy guide is fabricated from SLM technology. SLM is selective laser melting. The design of the placement of the implants, the bone reduction, the planning of the case is handled in one software, but the actual designing of the Chrome and all the components that involve Guided Smile are made in third-party softwares. So we design them in CAD, in 3D, and then we export those STL files and we print them using selective laser melting. Don't really need volume for that. But it's essentially a vat of chrome cobalt, and the laser contacts the surface of this vat, and it incrementally builds layers of chrome cobalt solidified into the shape of Chrome Fixation Base osteotomy guide and partial dentures. It's the same technology we use to fabricate partial dentures, so it's fascinating. So if this were to continue for about 2 to 3 hours, you would see our products emerge. Kind of fascinating technology. Before this, really metal was not available. You could do a conventional casting, not as accurate as we all know. And you could do some milling of titanium, but it's quite expensive, time consuming, a lot of tooling involved. So really selective laser melting is what made this possible. So the osteotomy guide will fit intimately with the fixation base. In fact, they'll fit flush and you'll find that when you're assembling them with your hands that they fit flush. The spoons or drills fit into the osteotomy guide. The implant timing is controlled with this little nub, which we'll go into some detail about later. And the chrome lock is what assembles the two together. When you receive the case, we'll go through a little bit of a QC, how you check to make sure that everything is properly made. Sometimes I put a note here at the end. Sometimes when implants are very close, could be angulation, but also proximity. And sometimes we'll have two different osteotomy guides for the same arch. Just putting the osteotomy, the hole in a different place, but we cannot put them close together because the implants are just too close. So you might receive two osteotomy guides. Often that is discussed in the online meeting. This is precision design. This is designed in special CAD software that manages the exact size of the osteotomy guide, the shape, the design. The inside diameter of the osteotomy guide is made precisely to accommodate the tool the doctor will be using during surgery. So whether you're using a spoon system or a drill hub system or a sleeve and sleeve, the inside diameter of our osteotomy guide will be 2/10 smaller than the outside diameter of the tool. And whenever you receive a case, you always want to inspect that the fit is right. Setting the sleeve for these osteotomy guides is a little bit tricky, a little bit of a tricky business. This is something that we have been doing since 2004. 70, 80,000 surgical guides. We're kind of experts at this point. We have detailed files on every guided kit system out there that we work with, and there are many of them. And so what we do is we use some very basic math based on the depth of the implant, the length of the drill, to decide where the sleeve is going to be placed, and that's called our offset, and the total length. And that is what we provide in our Sergey Mat as instruction for which tool to use during the surgery. Most systems, fortunately, when we set our sleeve, the drill or the tool bottom out, and so you just literally drill to depth based on an equation that we formulated when we set up these cases. There are many guided kits on the system in the country. Worldwide, I understand there's hundreds and hundreds. Sometime maybe even 10 years ago, I heard that there were maybe 400 implant systems in Europe and maybe 40 to 45 here in the States. So obviously those numbers are higher now. Back then, they didn't all have guided kits. Now, almost all major implant companies have developed guided kits. We have all the information on the guided kits on the screen and a few others since this program was put together. If you use an implant company that we do not have the guided kit information for, it's a very simple process. You can physically send us the kit. That's the best way to do it, or put us in touch with the implant company, with the rep, and they have measurements that we use when we design these cases. As an alternative, which we really recommend that if you're placing, for instance, a Straumann implant, use the Straumann Guided Kit. That is our preference. That's what we recommend. But if you need tools, we do have spoons, a selection of spoons that we can sell you for maybe for one particular surgery or a few surgeries, but then after, I would definitely suggest buying the fully guided kit. These are all the sleeves in our armamentarium. There are an inordinate number of sleeves for all these different systems. Now, most of the time with Chrome, we don't put a sleeve inside of the guide. We'll talk a little bit about that down the road. But managing these surgical guides it's quite daunting. These are all guided kits. This is an assortment of drills and spoons that we have. These are all OEM tools that we have ordered from the implant companies. So when we fabricate an osteotomy guide, before we ship it, we insert and use the same tools that you will in surgery to make sure that they are designed perfectly, ready for you. There is something that's very important to know about guided kits. Not all kits are quote unquote fully guided. Many of them are partially guided. And this is just a small selection of them, but fully guided means that the drill and the implant is controlled by the guide. So many of these systems that were set up do not control the implant, but merely help create the osteotomy, and then the implant is placed essentially freehand, sometimes through the guide, but not managed by the guide. So often there's a gap. I'll show you some images of that coming up. So that would be on the right here, partially guided kits. These three control the implant, but they do not control the drill. And you'll want to know that, and that's okay. That we've planned thousands of cases like that. It works very well. I kind of think for a tricky case, full arch, lots of angled implants, it's probably better to have a fully guided kit so that you have the depth control perfect and the rotation perfect. These were also all spoon or keyed systems. So you'll have some type of device that you put into our osteotomy guide that manages the drill. There are also drill hub type, where the kit just has an assembly of drills with hubs. And so the drill simply goes into the osteotomy guide, and that is how the whole the osteotomy is managed. You don't need a spoon or a key. It's a spoonless system. There's also on the right here sleeve and sleeve systems. Those have been available for a long time. They work very well. They can have a little bit of play in them, but frankly, a lot of these systems do have a little bit of play. And that's okay too, as long as trajectory is controlled, and then when you're finished, the bottoming out of the drill is controlled. So I have a sample of a let me get the volume right, of a key or spoon type system. Keep it in the beautiful chrome package. We'll remove the fixation base, attach it to the osteotomy guide, put them together, and then use your spoons just to verify that your spoons are the same as our spoons, which they will be. But verify that they fit pretty intimately in each of the sites. Good. This is just a starting 2.0 in a Nobel kit. This implant is going to be larger, so this has a little bit larger of a spoon. You'll find that with all of these systems, even with the machined OEM manufacturer sleeve and spoon, that there's always just a little bit of play in the guide. A little bit of play, not much, but you find that when you're at the apex of the implant, there could be a little bit more play than you're accustomed to. The idea is that you drill, that you hold the spoon firmly, flat and flush, and drill to depth, and you'll be in the right place. QC. Okay, I think I'm gonna leave the volume the way it is. So here's an example of a key or spoon type system, just a little bit different. Neodent fully guided kits. Neodent offers two primary kits, one for the CM line of implants, one for the GM line of implants. The CM and the GM both are a keyed or spooned system, meaning the osteotomy guide accepts the spoon. The spoon goes in the osteotomy guide. This is a 2.0. The pilot drill goes all the way to depth. That controls the depth and trajectory, angulation, everything of the osteotomy. Then you would move to a bigger spoon, drill to depth in a 3.5, etc. Our osteotomy guides generally come as printed metal, 100%, to manage the drill. If requested, we can put Neodent's OEM, original manufacturer, color coordinated sleeves. We charge a little extra for it, but there's a little bit of peace of mind, and there is a little bit more of intimacy with how the spoon fits in the guide. So that's an option. You can see the colors clearly here. and Neodent nicely matched the sleeves with the color. This is a spooned or keyed system. Okay, this is a little bit different. This is a Zimmer Guided Kit. We've made many cases with it, but it does not have the implant control. It only has the guided control. Let's just watch this video. This one's a quick one. Zimmer Guided Kit. Zimmer is also a spoon system. A spoons and B spoons. This is discussed during the online meeting, which spoon you'll use, and then it'll also be noted on the Sergey Mat. So with all spoon systems, the spoon is selected. This is a 3.4, so it's already a little bit into the sequence, but the spoon goes into the guide, drill goes into the spoon, the spoon controls the depth and trajectory of the drill until the osteotomy is created. Then the osteotomy guide is removed and the implant is placed with a handpiece or with a hand driver to depth. Not quite as much control as a fully guided kit. Half the kits are partially guided, half the kits are fully guided. If you're deciding on a guide, really recommend using a fully guided kit, but either works. So often in the middle of surgery, we get phone calls. Why does my implant not fit in the guide? And the answer is it's not supposed to. Highly recommend having the implant rep, knowledgeable implant rep who knows the guided kit well there for the first surgery, second surgery. They can help. They can also have a phone a friend. They can dial into tech support and just to confirm what's going on. So this is an example of a hub type guide. There are many like it on the market. In fact, this one seems to be becoming more and more popular. So let's go through this one real quick. R2 guided kit from MegaGen. This particular kit is in the spoonless, sleeveless, keyless type category. In other words, the drill itself has a hub on it, the shank of it, the hub, the outside diameter almost matches the inside diameter of our osteotomy guide. And so you don't need a spoon or a key to manage the drill. The drill is simply removed from the kit, inserted, and drilled to depth. This system is very simple to use. Normally you start with the shortest, and you always want to be inside of the osteotomy guide before the point hits the bone. That way it is completely controlled. If you hit the bone here and then start to go in, you'll be off trajectory, off angle. So goes in, touches the bone, and then drill to depth. And after you drill that site, then according to the length of the implant and the size of the osteotomy, you just simply go through this protocol. So the next drill is the pilot 2.0, drill to depth, remove, go to the next depth, all the way to, in this instance, 11.5 to depth, and then you would drill over to the size of your implant, and that is your osteotomy. Again, these videos are not supposed to be instructive for the actual surgery, but undersizing is generally what's used in the maxilla and sometimes in the mandible. But as far as the system goes, keyless system is very easy to manage during surgery. All right, so different types of systems, 4, 5, maybe 6 different kinds out there, and just, of course, be aware of it, study it, know it inside and out. The worst thing that happens in surgery is, which drill do I use? What's my procedure? What's my protocol? Leads to real problems. So this is this slide here. It just shows a few of the systems where we place OEM sleeves in the guides. And as I mentioned, we do charge a little bit more for it, but they're color coordinated. They also all include I think just about all of them include a slot on top of the guide that would indicate the rotation, gives a little bit more assistance with rotation too. So these systems on the left come with OEM sleeves in the guide. All cases come with a Sergey Mat. A Sergey Mat is something we developed recently. This will help to manage the flow of the surgery. All the components are imaged here. So the osteotomy guide, the fixation base, you can visually see in the mouth and then up on the wall or on the cabinet or or even on the TV screen, we can provide this as a JPEG. But you can confirm that this is what the fixation base looks like in the mouth, which is important, especially on a maxilla, really soft bone. Something could happen during the installation. It could be a little bit crooked. Really rare, but it could be, and you could use this image here to make sure that it's correct. And then sometimes you can also use this just to confirm the position of the osteotomy guide. The osteotomy guide often looks lingual to the ridge, especially in the anterior. It looks lingual, but that is because it is hovering above the bone. It is only designed to put the implant in the proper position in the bone. And so if you find that the osteotomy guide looks lingual, it probably is not. And I would suggest taking a tool, a drill or a spoon and a drill, dropping them in, putting the drill all the way down to the bone, and making sure that you're in the right position. Just a little trick. The Sergey Mat has every implant site controlled, and every site has the tooth number, and then it has the entire drill sequence. Some are simpler than others. The Zimmer Biomet, this is for a navigator kit. There are many components to their many lines of information to their guided kit. It could be a little intimidating at first, but really once you learn it, it's an excellent system. In fact, they have one of the best rotational control systems available. BioHorizon is a simpler one. You just simply color coordinated WP, wide platform, has your implant size, there's your drill length, color coordinate with your spoon, and off you go. This is Straumann, this is MIS, all have their little nuances and instructions, and just learn them, know them, and surgery will go great. The other part of the Sergey Mat, which it's literally rolled up in the box, you unroll it, you lay it out, it's large. In fact, we print these on 47-inch pieces of paper. The main part, the wide part, is the part that's the visual, and that will be up on the cabinet. The part that goes down on the countertop is the Sergey Mat, and this is a really neat apparatus. You lay it out and you put all of your parts on the actual mat. And I have this picture here because this is how we used to do it, and it was much more random, right? Well, you put the teeth in order, 2, 3, 5, 7, 12, etc. But in this instance, you would put 4, 8, 9, 12, put the actual implant box on the implant site, pick the multi-unit abutment. Here's 30, 0, 0, 0, 30, place them on the mat, place 2 sets of temporary cylinders. We'll talk a little bit more about why there's 2 temporary cylinders tomorrow, but organize your parts. Here's surgery we attended last week, a couple of them, and you literally put it down, lay out all your parts, and then when you are in the middle of surgery, you know where your parts are, as opposed to not knowing where your parts are. If they're in a box, they're just kind of laid on the counter. It's really a handy tool. That's the Sergey Mat. And the images are very high quality. So if you want to zoom in on them on a computer screen through a JPEG or a PDF, or if you want to post them close to you, you will be able to use it as a nice defined tool during surgery. I want to thank, Dr. Lee. She's our local dentist. She's the one who we showed the full Chrome surgery at the end of the meeting yesterday, Dr. MegaGen Lee, and then the denture guy, James Anzalone, friend of ours. He completes a lot of these Chrome guided smile cases. Actually, I think I have a nice slide of them coming up, but he completes a lot of these cases with us in town. So controlling the depth of the drills and the site. This is MegaGen. This is a hubbed tool. I put this image in here because I think it's critical that that we all know the difference between plastic guides and metal guides. This is a beautiful image. This was taken by Dr. Isaac Towell, who's a MegaGen KOL. Actually, he's one of our Chrome KOLs. And he and Dr. Gans used the MegaGen system with our guided kit. They take some beautiful photography, but you can see clearly irrigation, visualization. You know what you're doing. through the entire surgery. You know how the drills and the implants are interacting with the bone, and always a good experience with Chrome, especially as far as that goes, the visualization of it. And then the spoon systems, right? So you have an osteotomy guide, the spoon goes into the guide, and then the drill goes through the spoon. I suppose there's pluses and minuses with both systems. You might find a little more play with the spoon system, but not that much more. And really, as long as the spoon is sitting flush on the osteotomy guide, and of course all the tooling is correct, you're going to find a nice intimate feel and a positive direction when you're drilling and when you're placing the implants. Something that's very important to note on our osteotomy guide is the indexing indication on the osteotomy site. I show this because this is the evolution of our osteotomy guides. I'll call it a long time ago, but in 2017, we would mirror the implant interface. So this would have been a tri-lobe Nobel, and then you would just rotate until you had the either the lobe or the flat side in the exact place that you wanted it. That got a little cumbersome with all the different internal connections, and so a little bit tough to deal with all the different systems. Then we went to just a strict straight hex in the osteotomy guide, which was nice because we always had a flat side. And so you would always line up your part either with the flat side, or with some systems, you'd line it up with a little notch here, depending on what system you were using. But then that got a little confusing, right? Because now you have a notch, you have a flat side, which one do you follow? A little confusing. So then we, early last year, we had a hex, and then we put a little notch on it. So then you knew, well, here's the notch, that's where you stop. Of course, it happens to be in the middle, and then you would use a sleeve, and it could still be a little bit confusing, but the notch would always be where you stopped. Then we got rid of the hex altogether and just put a notch. And today, which I kind of think is the best of this evolution in this process, is the nub, as we call it. So we put a little square here, and this is where your instrument will stop rotating, and that is how you control. That is how you control the rotation of the implant, which is extremely important for angled implants. For straight implants, they'll always be round. There'll be no nub. It'll just be a round cylinder, because we don't care about indexing the same way on straight implants, only on angled implants. So I made another video that shows the significance of controlling the rotation of the implant. This video will show the effects of having an implant that is out of rotation, not in the preset rotation as planned. When we meet you online, we control with you the exact position of the implant, but in surgery, you'll have to control the rotation. It'll all be based on this little nub right here. We place this only on angled implants. Straight implants will not have this little indicator. Let's demonstrate what happens when the implant is off rotation. Let's add in the cylinder. So this is the trajectory of the implant and the drilling sequence and so forth, the drills. This is the angulation of the temporary cylinder and the multi-unit abutment. If we add the restoration on, this is the prosthetic that'll be delivered at surgery. The position of the temporary cylinder is ideal. It's perfect, right in the middle of where the temporary cylinder is going to come through. That's where the hole is designed, pre-designed in the prosthetic. However, if the implant is rotated off axis, is rotated out of position, look at the significant change in the position of the screw. With just slight rotational variances, there can be a serious adverse effect during surgery, which can cause long-term issues with screw position, cantilevering, prosthetic design, and so forth. During surgery, the main effect is that you'll have to adjust the prosthetic. So follow the nub, know the guided kit very well, and have a successful implant placement with the correct rotation. All right, so I kind of beat a dead horse on this, but just really want everyone to be on the same page with that. Know the system and know how to control rotation. We see many cases coming in with the holes on the prosthetic opened up because the temporary cylinder was going in the wrong direction. We're going to show some examples of that tomorrow during the prosthetic conversion portion of this series. So this is, again, this is a MegaGen. This is Dr. Towle again, and this is where he is using the flat side. And please forgive me, I wish I had images of our brand new design with the nub. You can even see that the metal is different now these days. It's much smoother, but this has a hex, but it still has the same purpose. The flat side is to match up with the index on the implant mount. So with this particular system, the green goes to the flat. And so you know that when these two match up, that your implant's in the right direction and that everything on top of it is going to be in the right trajectory. So as mentioned before, not all systems are fully guided. You know, in this system here, this system does have depth control of the implant. The top, the bottom of this driver, the implant mount will stop at the top of the osteotomy guide, but it will not meet the inside of the osteotomy guide. So this is essentially freehanding the trajectory and controlling the depth, which is okay. It's not always a major problem. Now, one thing that can happen is because of manual dexterity, different strengths of people's hands and force and so forth, you can push an implant a little bit off trajectory, and then hopefully end up correctly. But you could end up a little bit off trajectory, and then you could get a little binding here. All right, so we want to be careful of that. As you're going in, you can manually force this in the correct trajectory. If you do not have the ability of placing an implant through the guide because of size, then it really is more of a freehand placement down to where the threads are at the ridge and torque. So just a gap. You can see that this could have a significant effect on the access and the screw positioning on the prosthetic, just this little bit of variance. Now, this is Nobel BioCare. It is a fully guided system for depth control, but it can have a little bit of play on the trajectory. This is DDI who shared these images with us. Thank you very much, Dr. Sandeep. Here's an example of a Neodent GM Guided Kit. They focus a lot on full arch, so they designed a nice system to control the drills and the implants. So fully guided kit. One thing that's interesting though, when we design these cases, we design, of course, the sleeve at the exact offset for their drill, whether it's the long drill, the short drill, and then the drill. If you notice a drill, there's no stop, which is curious. It just has different lines here of where you would visually stop turning the drill. It works very well. We make a lot of Neodent cases. My advice would be to put a stop on it. I know they have their reasons, but it'd be nice to have a stop. However, the implant is totally controlled. Their implant mount fits intimately with the inside of our chrome, and then they use a little divot here to control the rotation. So you would line the divot with the nub. I like all those real technical terms. Divot and nub together, and you know you're in the right rotation. It's a nice system. And then this is a Straumann Guided Kit. They have a nice system for controlling rotation, a defined, distinct vertical line on their mount that you line up with our mark. Of course, that's the old mark. Line it up with the nub, and you're all set. Nice system. And I added this slide today because I wanted to thank Dr. Lee and James for they do a wonderful job in surgery, and then they do a wonderful job of documenting these cases. James, I don't know, he's got some fancy camera, but he documents every single image perfectly and shares them with us. I really appreciate that, James. And this is, just since we're in here, this is Joe Holler. He's top Straumann rep here in North America, become a really good friend of ours, great supporter of Chrome Guided Smile. Chris is our national sales manager, Kelly, and Dr. Lee. Dr. Lee. The carrier guide. All right, so this program was designed for two parts, right? The osteotomy guide and the carrier guide. The carrier guide is something that is serves a number of very key important purposes as you're going through these surgeries. The carrier guide assists determining enough bone reduction has been completed. So when you think you're finished with bone reduction, you take the carrier guide. I'll have some images of this. You take your carrier guide and you try it in, and if it fits passively, then enough bone has been reduced. It's 3 millimeters thick, so it simulates tissue thickness. And then also the bone reduction. It also can help with holding the flap at bay, as I say. It also simulates tissue thickness, as mentioned, and it delivers the nanoceramic prosthetic, and it delivers a rapid appliance for pickup, a nice stable platform for the conversion. And it also aids, which is very important, it aids in directing the abutment screw into the implant and the rotation of the multi-unit abutment. So the first step, the first thing we do with a carrier guide is when you're done reducing the bone, take it and try it in passively. Try to seat it into the chrome locks, and make sure that it fits and it doesn't warp. There isn't any pressure, and it should drop right in. Now, sometimes it might be tissue holding it up and not bone. So just be aware to look for both. If it passively seats, then move on to the next phase. Otherwise, adjust the bone, or sometimes you can see this here, this will hold up the carrier guide. Tie a stitch, do a little stitch, hold it back, and then the carrier guide will sit better. The carrier guide features, let me see here. A few things. Again, it's going to fit passively. The loops, just like the pin guide, should fit right down into the chrome locks. If for some reason it does not drop in, you don't always want to blame the bone or the tissue. There may be something down in the chrome lock. I've seen where the pin guide, the plastic on the pin guide, a little piece of the plastic is broken off. It's clear, it's down in the box, and you cannot see it unless you look carefully, and then you use your Explorer or something to remove it. So if it's not seating, if your carrier guide is not seating down inside the chrome lock, it's either your chrome lock is pushed in, the plunger's already in and you can't seat it, or there may be some debris down in there. So be careful with that. It is plastic. It's a little bit delicate, so just be careful when you're using it. And then just like with the, got a lot of animation here. You want to remove it vertically. You don't want to torque it out, in one direction or another. Remove it vertically so you don't break the little loops off. Terminology. As I mentioned, it's 3 millimeters thick to simulate tissue thickness. The carrier guide males. So these are the males, and there's females inside of this prosthetic. They fit together. And the holes may need to be adjusted during surgery. We're going to go through that a little bit. But essentially, they are the same size as the hole on the prosthetic or on the carrier, on the rapid appliance, and they should be just right. Chrome locks are delicate, so be careful. We'll talk about this shimming technique tomorrow as a fix for whenever there's any bite issues. I have seen in some photography and being chairside that doctors and technicians like to open up the carrier guide before surgery. I think you'll find that the plan and the guide and the implants will be in the right place just about every single time. You can have a little bit of a challenge with angled implants without the rotation being correct or the depth being correct. That has an adverse effect, but really the holes in the carrier guide should be in the right place. And if you do need to open them up, it's okay, because we use gaskets to block them out. Every angled implant will have a notch right here. Will have a notch, and that notch is strategically placed right in front of the abutment screw. So this is the trajectory of the implant. This is a trajectory of the screw, of the drill. This is the way the implant went in. And the screw and the driver that you put the screw in will fit into this notch as an indicator, and then put your screw in. Every one will be in the direction that the abutment screw is placed in the implant trajectory. So you can use it as a guide. So in other words, if you find that that the access hole is over here, it means the implant needs to be rotated. And would highly suggest, first of all, using the guided kit to make sure the implant's in the right rotation, but removing the components and then rotating the implant back into the proper position, or into the next slot to having it in the right position. It makes surgery go much smoother. Sometimes because of bone limitations and the limitations of angulation of abutments, divergent temp cylinders does not mean the case went wrong. It may be the way the case was planned. In fact, I believe that these were straight implants. But to put a 17 degree was too much, and a 0 degree was too much the other way. So we went with this plan, and there's a little bit of divergency, and the prosthetic will just sleeve over the two. Just an example of using the holder, the carrier of the abutment. Just about every system has it. So when you receive your abutment, it also comes with this little handle that screws into the prosthetic part of the abutment. This is how you deliver the abutment to the mouth and hold it in place. Now, if the abutment is fitting into the implant properly, it drops in, you can tactily feel it in there, and this hole is in the right direction, is emerging where the square is, you're good to go. This will be vertical, the screw goes in, move on to the next one. If you find that this is off angle, it is because, more than likely, I mean it should be, because the implant is off angle. Rotate the implant, straighten it up, and then move on. Now, I know that, again, this was not going to be a surgery type meeting, but if you find that there are torque issues with tightening down the implant more or loosening it up, perhaps you go with a crooked temporary cylinder and adjust the prosthetic, but it would be best to rotate the implant. Sometimes on the angled implants, if we don't have enough space to cut out a notch, we'll just make a little slot in there. We don't want to weaken the plastic by making a notch. Kind of funny here, avoid flared temp cylinders and flared tempers by making sure that the osteotomy guide and the carrier guide are used as instructed, because at the end of the surgery, getting close to the end, if all the temporary cylinders are divergent, the prosthetic won't fit. It's quite aggravating to have to adjust the prosthetic to fit the temp cylinders. It should be vice versa, making sure that they're all parallel. And then also, we recommend when you order your parts, when you order your abutments, that try to order all of the same collar heights. Now, there are some limitations with systems out there, but for the most part, we recommend ordering between 2 and 3 millimeter collar heights. Those work best with tissue thickness. They work best with our carrier guide, and we give you a report as soon as we're done with the online meeting. And in that email that we send you, makes the recommendation for collar height, because if collars are too high, then we end up making a prosthetic that goes up and over them, and that is a consequence. We don't like to have to do that, and in fact, often it's best to swap out that abutment for a lower collar height down the road. If the collar height is too short, then during surgery, the collar height is down below the tissue, and now you have a prosthetic that you're trying to push down, and you're trying to displace too much tissue to get down to the abutment. So we recommend 2 to 3 millimeter. And you will find that, for instance, with Nobel Guided System, Nobel implant, their multi-unit abutments on a 30-degree angle only come 3.5 and higher, 3.5, 4.5. So on the angled, order 3.5, and on the straights, order 2 or 2.5. All this can be discussed in the online meeting. All this can be discussed with your rep of what's available. So, taller collar heights would have caused a problem here, would have touched the plastic, but still, you still want to follow the rules of collar heights. It's good for long-term prosthetic design. And finally, trust the plan. The plan is completed in sophisticated software. It's exported into third-party software where files are made. It's the human intervention in this is minimized by this being a fully digital system, meaning that the SLM designed fixation base osteotomy guide are very accurate, and you can trust them to put the implants in the proper position. So that is osteotomy guide and carrier guide discussion. I'm going to open this up to a chat. First question. The notch on the carrier guide comes in handy when you are using the guide to place the implants. However, when we are using Zimmer implants, we will not be seeing those nubs. Yes, that's a great point, Dr. Heba. And in fact, there are a few systems out there that don't allow you to place the implant through the guide. On those systems, you have a couple of options. One is you can use the carrier guide for the rotation, because that has the notch. And the other is you can make a line or a mark on the fixation base that's right below the nub, and that can help with the rotation too. Is it perfect? No, it is not. It's a little bit limited. But that is an issue with a partially guided kit. Can you comment on the use of Versa with Chrome? Thanks. Yes. Thanks, Jake, or Dr. Kiefer, excuse me. We have made many guides with the Versa system. It's a little bit tricky, because it has the C in the opening, but they developed an entire new line of Versa drills. We are very, quote unquote, versed in it. Not an issue at all. So please send them. I think they have a tremendous product. Are you set up for Sweden Martina? We are. In fact, their rep was here about a month ago, stopped in, and just to confirm everything is A-OK. We have their guided kit, we have their spoons, we have all of their measurements, and we have completed kits for Sweden Martina. Yes, no problem. Any other questions? Okay, if you'd like to post a question, please do. I'll open up the chat right after we go through this case.